So in this video, we're going to do problems 21 to 26 of the midterm review packet. For 21, you should see that you have a function raised to a power. So you're asked to find the first derivative. So you would say f prime of x equals, using the power rule and the chain rule combination, bring down the power, 7 times 2x squared plus 5 to the sixth power. Now you need the chain rule of the inside. So take that derivative and you get 4x. So therefore, f prime of x equals, combine the 7 and the 4x by multiplication, and you get 28x, and then you have a 2x squared plus 5 raised to the sixth power, and that is your final answer. Okay, on the next slide, we'll do 22. Okay, for 22, taking the derivative, what I would highly recommend that you do is take a second to rewrite it. Whoops, I'm so sorry. Let me undo that because I haven't taken the derivative yet. So, rewriting it, let me just start all over. Rewriting it gives me f of x equals, put your paren around x squared plus x, and raise that whole thing to the 1/3 power. Okay, so now you're ready to take the derivative. It's going to be, again, the power rule and the chain rule. So f prime of x equals 1/3 times x squared plus x to the negative, so 1/3 minus 1, so 1/3 minus 3 over 3 is minus 2/3 times that derivative, which is going to be 2x plus 1. Okay, we're going to clean that up and kind of put it back in the form in which it was given to me. So I have 2x plus 1 is in the numerator because it doesn't have a power. 3 is in the denominator. Take the cubed root and then take x squared plus x and raise that whole thing under the radical to the second power. Because it's in the denominator, I know it was a negative power. It no longer is. So this is your best answer. Okay, in the next slide, we'll do question 23. So for 23, I would recommend that you do the quotient rule. So doing the quotient rule, I'm going to say f prime of x equals low. So write it just the way you see it. Don't touch anything. D high, that's just 2, minus high, put it in parens, D low. Okay, bring the 6 in front. Then we have x squared plus 2x plus 5 to the 5th. Then take the derivative of the inside, which will be 2x plus 2. And the whole thing's over the denominator squared. Don't forget that piece. Okay, so now I want you to look. I have a power of 5, a power of 6, a power of 12. The highest power they have in common will be the 5. So therefore, what I'm really doing is factoring out the x squared plus 2x plus 5 to the 5th power in the numerator and in the denominator. Okay? When I do that, this becomes a fancy 1, so that cancels out. It is gone because I have the same term in the numerator as I do in the denominator, so therefore same over same is 1. I no longer need that in my problem. So what I'm left with is 1 of the x squared plus 2x plus 5. That is multiplied by 2. And then minus, let's combine some things. So I have 6, and then I have a 2x plus 2. What if I factor out a 2 from there? Wouldn't that be a 12 then? So 12 times 2x plus 3. Now, because I divided this by 2, or factored out 2, rather, I'm going to get x plus 1. So do you see that? And then it was times that term to the fifth number, which I took out, so I don't need it any longer. So basically, I've eliminated this. I've made this denominator 7. I've made this 6 1. That's what factoring out the terms raised to the fifth power did for me. Okay, not done yet. All over x squared plus 2x plus 5 to the seventh. Okay, so what I would do at this point is I would FOIL this term right here. So I would FOIL that off to the side. Okay, so I'm going to continue saying f prime of x down here. But over here in this little working box, I'm going to FOIL that. So I'm going to get, if I said 2x times x, that would be 2x squared plus a 2x plus a 3x. So that's plus 5x plus 3 times 1 is 3. Okay, so above here, maybe I'll pick a different color. I'm going to say that this expression is equivalent to 2x squared plus 5x plus 3. Okay, so what do I have now at this point? So let's go back to my original color. And I'm getting that. My final answer, I'm going to pull. Let's see what I want to do. To think about this for a second. Our best approach, looking at what I have a 2 in place. I have a 12 in place. I believe what I did was to distribute all the terms. So distributing the terms, so let me do this. I'm going to erase this, and let's distribute some terms. So if I distribute some terms over here, I'm going to say, okay, and this is my working box, so that's gone. And why don't I just get rid of it since it was my working box? So getting rid of this. There we go. I'm now ready. Whoopsies. So I'm going to get rid of it this way. I'm now ready to do some more math to clean things up. Okay, I'm just going to clean up my screen here. Okay, that's much better. Okay, so continuing. F prime of x equals. Go ahead and distribute. So I have 2x squared plus, carefully, 4x plus 10. Then minus 12 times 2x squared, so that's minus 24x squared, minus 5x times 12 is going to be a 60, right? So a 60x, and then minus 12 times 36 is minus a plain old 36. That's my entire numerator over this denominator. X squared plus 2x plus 5. And remember, now it's raised to the 7th. Okay, so let's see what we can do when we combine terms. Look at the x squares. I end up with negative 22x squared. That takes care of this and this. Look at the linear terms, the x terms. I end up with negative 56x. Takes care of this and this. Look at the constant terms. I have 10 and a negative 36. So that's a negative 26. And that takes care of them. And I'm still all over x squared plus 2x plus 5, quantity raised to the 7th. Okay, what I would do at this point, I'd factor out a negative 2. That gives me a positive 11x squared, a positive 28x, and a positive 13. All over x squared plus 2x plus 5 raised to the 7th power. So just checking my other work. Yep, I'm good. This is my final answer, and that's the best answer. Now, a word about factoring. If I could factor this, I would. I cannot. There are not any two numbers that multiply to 13 times 11 and add to 28, and that's why I'm done. If I could factor it, I would factor it. But that's the best answer for number 23. And let's go on to question 24 on the next slide. Okay, here's question 24. So I have a trig function times a function raised to a power. So I'm going to need the product rule. So to do the product rule, I'm going to say, okay, f prime of x equals left, right what you see, d right, which is 2 times 3x plus 4 to the first power now, times the derivative of the inside, which is just 3. So I've done left d right, plus right, write down what you see, 3x plus 4 squared, d left. That's going to be secant squared 10x times 10. So I'm going to bring the 10 in here. That came from the chain rule of the angle. So 10 secant squared 10x all over, all over nothing. Okay, so I lost my head, so let me just backtrack there. So we're done. Now we have to just clean it up. Okay, because we're doing product rule. So left d right plus right d left. Look what they have in common. It looks to me like the only thing in common is going to be the 3x plus 4. So let me pull out a 3x plus 4. That's greatest common factor factoring. You need to have your parens as a complete term. Okay, so then what else can I pull out? I have a 2, a 3, and a 10. How about if I pull out a 2? So let me I'm going to do this. I'm going to get rid of my equal sign for a sec. Put the equal closer, and then pull out a 2 in front. So I've taken care of the 2. This becomes a 5 now, just to keep track of things. And I factored out the 3x plus 4. Use your bracket. I now have 3 times tan 10x. That takes care of this and this. And then plus, I have 2 and I have 3x plus 4, so I need a 5 still, a 3x plus 4, and then now I have a secant squared 10x, and I'm done. Okay, so let me compare that to my other answer, and that looks good. Okay, so that's good. So that completes 24. Let's go on to 25, and we'll do it on the next slide. Okay, we're going to try to do 25 and 26 on this slide, and we'll see how we make out. Okay, so first off, what I would do if I was doing f of x for 25, I would say, okay, that equals, this looks fine the way it is, sine x, but then I would say minus cosine of 2x and square that guy. Okay, so now let's take the derivative. We're working from left to right. The derivative of sine x is just cosine x because there's nothing fancy going on. The derivative of the angle is still going to be just plain old x, so I don't need the chain rule in that case. I do need the chain rule and the power rule here, so for the next term. So let's do that. Minus 2. Okay, so what you're going to do is you're going to write down exactly what you see, don't touch anything, and then raise to the first power, and then times the derivative of the inside. Well, that's cosine. That's going to be negative sine of 2x, and then time the derivative of the 2x, so that's going to be 2. Okay, let's clean that up. So f prime of x equals cosine x. Now, I have a negative times a negative that makes it a positive. I have a 2 times a 2 in the front. That becomes a 4. And then I have cosine 2x sine 2x. And that looks good to me. So 24, I would agree with that. And I can't do anything else with it. So I'm going to leave it be there. Now, let me just put a line here. We'll put a line. And I'm going to handle the next problem right here. So why don't we change colors? And I would say, okay, this is a simple one. Let's bring this down here. And I'm going to say, okay, if f of x equals cosecant of 2x, you've got to memorize these derivatives, f prime of x equals cosecant again. Now, do I need a negative? Yes, I do. So it's negative cosecant 2x times cotan 2x, but then times the 2, because you need to have the derivative of the angle as well. So let's write it one more time. F prime of x equals negative, bring the 2 up, cosecant 2x cotan 2x, and we are done. And that's the best form for that answer right there. And so that concludes questions 21 to 26 in the review packet.